In this video, we're going to talk about converting exponential forms from the form ab to the x to ae to the kx, and we're given that f of x equals 5 times 0.81 to the x. Now, we'll also talk about the different information we get. So, the initial is the same in either of them. Notice it's a and it's a, so we already know the initial for the other form. What's important is to figure out what's going on. Now notice with the base and the rate. Notice here the base is less than 1, so we have a decay rate. We have some exponential item that is decaying, and now our decay rate is not 81%, because that's the amount left. It's 1 minus 0.81, which is 0.19, or we have a decay rate of 19%. Now, depending on what x is measured in is what this decay rate will be in. So for instance, if x is in years, this would be an annual decay rate. If x was in months, it would be a monthly decay rate. So it depends on what x is measured in. But that would be per change in 1 of whatever x is, we'd lose 19%. Now, converting the forms, we already know that a is going to be 5. Now, we have to look at how these line up. So here we have the b in this form is equal to e to the k in this form. So, b equals e to the k. We can solve this with logarithms. This means that k equals the natural log of b. So k was the other part that we needed. We know that b is 0.81. So k is equal to the natural log of 0.81, which, if we use our calculator to help us out here, we can do the natural log of 0.81, and we get roughly, notice it's negative, we'll talk about that in a second, 0.2107. Now remember, we said it was decaying. So in this form, for decay, we want to see that the base is less than 1. In this form, we need to see that the k, our rate, is negative. So our model in this other form, we could write it as f of x equals 5 e to the natural log of 0.81 times x. Or we could use our approximation. So 5 e to the negative 0.2107 x, but we will lose a little bit of accuracy with this. Now, we still have a decay rate, and we know it because it's negative, of 21.07%. Now, like we said on our last one, that's our annual decay rate, or per unit change in our input. This would be a continuous decay rate. So again, we get a little bit different information from each model.